So we started looking at off policy Monte Carlo methods in the last class, right? And let's continue from there. So people remember importance sampling? Yes. This is something like expected value of what was that? Right. So expected value of f of x, where x is sampled according to p, can be given by expected value of f of x into px by qx, where f is sampled from q, x is sampled from q. Okay. So this is the basic idea behind importance sampling, and we saw some expression for it. So which was essentially, so notice that there is no approximation here, right. So this is the approximation. Do we do a 1 by n? Right. We also wrote another sampler, which was okay. So this is the, I think this is called the weighted importance sampling estimator, right. This is a weighted importance sampling or normalized, right. So different ways in which people call it, okay. So how are we going to use it in Monte Carlo learning? So what are the samples we are talking about here? What is our f of xi, right? What is xi, what is f of xi, right, and what is p of xi and q of xi? What are these quantities in a Monte Carlo setting?
We use the policy we use.
Start with x. Exactly. It is the trajectory. Why are you so doubtful about it? You should say trajectory.
Trajectory.
Yeah, okay, good. Well, I am happy nobody said it depends. Of course, it doesn't. Okay. So in this case, xi is the trajectory, and so you are drawing samples. You are drawing trajectories. And what is f of xi?
Evaluation on
The return. Right. F of xi is the return on the trajectory. Okay. Now, what is p of xi?
policy.
A little bit more.
No, the policy we use.
Little bit more. You have to relate it to xi, right?
Evaluating that policy on that.
Probability of that policy.
Probability of the trajectory. Given that I am following policy pi, right? So p of xi is the probability of the trajectory xi. Given that I am following the policy pi, according to which, for which I am trying to do the evaluation. Okay. So what will be qxi? The probability of the trajectory under the policy that I am actually following. Okay. So for to syncing up with the textbook case, we will say pi is the policy that you are interested in, and mu is the policy that you are following. Okay. Sometimes it is called the behavior policy. So let us say xi is some trajectory, okay. So x is some trajectory which starts off with some state s naught, right. What will I do after that? Right, so that will be a trajectory. Correct. So there is some problem. What will be the probability? What will be P of xi? So in fact, I can leave out the r's because they will be captured in the f part, right. So I can actually ignore the, I mean the r's are there, right, but when I am computing the probability of xi, I can ignore the r parts because they will be captured in the f, okay. So let's put them back, yeah, yeah. So what is the probability of xi? What will it look like? Huh? Pi of a naught, it looks like a q, a naught given s naught into p of s1 given s naught comma a naught into anything else?
Starting 0.
Right. So I need a some probability that I will start with s naught, okay. That is a universal thing. Is it fine?
We have taken the probability of A not B.
Huh? Okay. So what will be q of xi? Right. So can we compute Pxi? Trick question. Huh? I need the p's, right? I need the p's. I don't know the p's. I mean, the whole idea behind going to Monte Carlo methods is we don't want the p's, right? Likewise. Exactly. But if you think about it, where we need p is only as a ratio with q. So I never need to compute p and q separately. All I need to do is compute the ratio. So if you take the ratio, what happens? It reduces to right. If I can write this as a product of the ratios, that's fine. Right. So I think that might be an easier way of doing it. So I mean historically, pi is used for both the product as well as the policy. So please disambiguate on context. Okay, is it clear? So now I know how to find the ratio Pxi by Qxi. So what would this guy be then? So if you think about it, a little tricky. I shouldn't have used I here. I apologize. Really apologize. Okay, we have I on the left hand side. I shouldn't have used I as the running variable, sorry. Okay. So what do we have here? So what does this correspond to? What does that weighted importance sample here correspond to? The expected value of f of x, right? So what is that? What is that? The value function, right? So the value function of some state, right? V pi of s, right? Some s, right? So essentially we have now V pi of s is equal to right. So I put a superscript in brackets I to denote that these quantities come from the ith trajectory, right. So this I equal 1 to n means that I am running n different trajectories. So I put this superscript to denote that they are coming from the ith trajectory, and the return is computed starting from state s. Okay. So likewise, I mean I need to have a thing here. So is it fine? So this is how I will do Monte Carlo policy evaluation, okay, in off policy fashion. Okay. So why do I want to get into off policy learning?
We can't always easier to some decisions.
Right. So this will allow me to explore a lot more states, right, than if I am following the policy pi. So I can get a larger sample of states values estimated and so on and so forth, and it could also be that maybe mu is a easier exploration policy than what I have with pi and try to sample from. So there could be a variety of reasons why I want to do this, and I encourage all of you to read the textbook, right. And yeah, I missed something in the denominator. I need a big pi. Thanks. That is just indicative, right? You all know what I missed there. So just fill it in. Okay. So there are a few tricks that they do in their book. They take this and convert this into an incremental method, where you can keep. I mean, you don't have to wait till you finish running the trajectory to compute this importance weight. You can keep updating it as you go along, right? And then you can keep updating this estimate also as you go along in the trajectory. You don't have to remember everything, right? So they give you all kinds of small arithmetic tricks to make it incremental, right? So again, I encourage all of you to look it up, right? If you are going to ever implement a Monte Carlo method, that's the way you will do it, not like this, right? So, but I'm really trying to get you guys to read the book, right? So somebody other than Sagar, I'm trying to guilt him into reading the book. Yeah. Anyway, great. So this is all fine for evaluation. So what do you do for control? Is there anything else you have to be careful about for control?
Single visit, every visit,
What's it?
single time visit or every visit.
Yeah, so how will it change? How will this change for first visit and every visit? Will it change?
We need action value.
Hmm?
We need action value.
We need action values. So, what is the problem with using action values? Is there any specific problem that you see with using action values? Okay, so I am going to let you guys actually go read the book. Okay, I am not going to tell you. Just go read the book and figure out how would you do off policy motor control. Okay.